Namaste one and all. Today we'll be learning regarding Coulomb's law. In the previous video, we came to know that a neutral body can be charged either by adding negative charges or by removing the negative charges. And we have learned some of the methods of charging, that is by friction, induction and by contact. And we also studied some of the properties of charges like quantization, and it also has some mass. So whenever a charge is transmitted, along with that mass is also transmitted. Now when we come to Coulomb's law, it tells us that there is a force of interaction between 2-point charges. So let us look what is meant by this force of interaction. So if you are having two unlike charges, for example here, one is positive charge and the other is negative charge. If they come closer, then there is a force of attraction between these two charges. So what I mean to say is, whenever there is an unlike point charges, they tend to attract towards each other. So similarly, if the charges are like charges, that is if both the charges are plus q charges or if both the charges are minus q charges, then there is a force of repulsion. So when the charges are unlike, then there is a force of attraction. If the charges are like, then there is a force of repulsion. So this force acts along the line joining the 2-point charges. So as you look over here, so this force should act only on the line joining the 2-point charges, and each charge exerts force on the other charge. So here in case of repulsion and in case of attraction, both the forces are acting along the line of joining two charges. Now, the force of interaction between point charges is given by Coulomb's law equation, that is force is equal to 1 divided by 4 pi epsilon naught q1 into q2 divided by r square, where q1 and q2 are the charge and r is the distance between the charge, and epsilon naught is the permittivity of the free space where these two charges are lying. So 1 divided by 4 pi epsilon naught can be taken as proportional to constant k. The value of k is 9 into 10 to the power of 9. So you need to learn this equation in order to solve the problems. Now here the plus or minus indicates the type of force, whether it's a force of attraction or force of repulsion. So if you look over here, if the charges are unlike charges, then there is a force of attraction, so it should be pointing inside. And if there is a charges which are like charges, then the sign would be positive charge, indicating that the force is acting outwards. You can look over here, the force is acting outwards, it indicates repulsion, and here the force is acting inwards, it indicates attraction. So whenever you get an answer of negative, you just need to know that the two charges are unlike charges. If the force, if you get it as positive, then you can say that the two charges are like charges. Let us see it with the help of an example. Before that, look over here. If both the charges are unlike charges, that is if one of them is positive and negative, so there is a force of attraction. Again, if there is a negative and positive, they are unlike charges, so there is a force of attraction. If both the charges are same, then there is a repulsion force. Again, if both the charges are negative, that is same, there is a repulsive force. What is the force? It is given by k into q1 into q2 divided by r square. So the value of k is 9 into 10 to the power of 9. Plus or minus indicates the type of force, whether it is a force of attraction or force of repulsion. Now let us consider the example. If there are two charges plus 2 coulomb and plus 4 coulomb which are separated by a distance of 8 meters, then what would be the force? Now when you look at the charges, both of them are like charges, so the result would be plus, indicating that there is a force of repulsion. So the help of the formula, we know that force is equal to plus or minus 9 into 10 to the power of 9 into Q1 into Q2 divided by R square. So 9 into 10 to the power of 9 into 2, this charge Q1, so this charge Q2 is 4 divided by distance is 8 meters, 8 square. So we'll be getting the value of 1.125 into 10 to the power of 9. So the result is positive. It indicates that there is a force of repulsion. So whenever the charges are like charges, that is both of them are of similar kind, then there is a force of repulsion. Now let us consider the same example. Here there is a minus 4 coulomb. So these two are unlike charges. So the one is positive charge and the another is negative charge. In this case, when you substitute the formula, so we'll be getting forces 9 into 10 to the power of 9, 2 plus 2 into minus 4. So the result is minus 1.125 into 10 to the power of 9. So the negative indicates that there is a force of attraction. What does it mean? There should be one positive charge and the other negative charge. So although the magnitude are same, the sign is different. So here the plus indicates there is a force of repulsion and negative indicates there is a force of attraction. So the sign gives only the direction and the magnitude is given by the value of the answer. So this is regarding Coulomb's law. So now we'll be considering the simulation of this Coulomb's law. So here there are two charges Q1 and Q2. Both of them are positive charges. Q1 is having a value of plus 10 microcoulombs and Q2 is having a value of plus 10 microcoulombs. They are separated by a distance of 10 centimeters. So each of them will be exerting force on one another. Since both the charges are positive charges, so there will be force of a repulsion between them. Since you know that when both the charges are like charges, there is a force of repulsion. But what is the amount of force? So that is given over here, which is 8.99 into 10 newtons. It is exactly around 9 newtons. So let us try to solve it with the equation which we have learned. So force is equal to K into Q1 into Q2 divided by R square. So the value of K, we know that it is 9 into 10 to the power of 9 into Q1 value is 10 microcoulombs. So it is 10 into 10 to the power of minus 6 into, so the other charge Q2 is again 10 into 10 to the power of minus 6 divided by, so the distance between them is 10 centimeters, 10 into 10 to the power of minus 2 whole square. So there is nothing but 9 into, so I can write this as into 10 to the power of 9. So this is minus 6, again this is minus 6. So 10, 10 and 10, so this would form plus 2. So divided by, so 10 square is there, so 9 divided by 100. So here 10 to the power of minus 2 to the power of 2, that would be 10 to the power of minus 4. When it comes above, that would be plus 4. So that turns out to be 0.09. 9 by 100 is nothing but how much? 0.09 into 10 to the power of, so this is 9 plus 2, 11, 11 plus 4 is 15 minus 12, so that would be 10 to the power of 3. So that would be equal to 9 into 10 newtons. So we got the exact value, it is 8.99. So it is exactly 9 newtons. So able to get the value of force which is equal to simulation. So now what we shall do is, let us bring this charge nearer. As we bring the charge nearer and nearer, you can look over here, the force of repulsion is increasing. Look over here, the force of repulsion is increasing. So this force of repulsion, this length of arrow is indicating the magnitude of charge. So now let us try to find what is the value of charge. So exactly at 2 centimeters, so the value is how much? 2.25 into 10 to the power of 3 newtons. So let us try to find that. So here we just need to calculate force at a distance of 2 centimeters. So here you can look over here. So it is at a distance of 2 centimeters. So at a distance of 2 centimeters means instead of taking 10 centimeters, I need to take it as 2 centimeters. So that would be 9 divided by, so 2 square, so that would be 4. So the remaining thing is, so 9 divided by 4 into 10 to the power of 3. So that turns out to be, so 9 by 4, so that is nothing but 2.25. So that is 2.25 into 10 to the power of 3 newtons. So look over here. So at 10 centimeters, the force was only 9 into 10 to the power of 1 newtons. Now look over here. So as you are coming nearer and nearer, so the magnitude of force is increasing. So look over here, into 10 to the power of 3. 2.25 into 10 to the power of 3. This is a big value. So and the direction is given by the sign. So look over here, the value is what? Positive. It indicates that it is in the opposite direction, indicating that it's a repulsive force. So if this Q2 was negative, instead of plus 10 microcoulomb, if this was minus Q2, that is minus 10 microcoulomb, so the magnitude would have been the same, that is 2.25 into 10 power of 3, but the direction would be towards each other. Then that would be force of attraction. So let us make this Q2 as minus 10 microcoulomb. So look over here, the direction is reversing. So look over here, the direction is attraction. Look over here, the direction is what? Attraction. So but the value, look over here, the value remains the same, 2.25 into 10 to the power of 3, 2.25 into 10 to the power of 3. So now since both of them are unlike charges, so there is a force of attraction, and in the answer you will be getting, since one of them is negative, the answer will be getting force is equal to minus 2.25 into 10 to the power of 3 newtons, where negative indicates there is a force of attraction. So this is the concept which you need to understand while solving Coulomb's law, and the force is along the line joining the two charges. So now you can bring this here, look over here, again there is a force of attraction. Look over here, when the arrows are pointing inside, it's a force of attraction. And if I make this Q2 as positive, look over here, it is arrows are pointing outwards, indicating that it is a force of repulsion. So it depends upon the distance. If the distance is increasing, look the length of this, which indicates the magnitude, so the force is decreasing. If the distance is nearer and nearer, so the force is increasing, indicated by the length of the arrow. So thank you for listening the concept. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.